Hello, and welcome to section number 3, Exceptions Handling in Parallel Code. In first video, we're going to discuss details of handling exceptions. Unhandled exceptions that are thrown by user code that is running inside a task are propagated back to the calling thread, except in some specific scenarios. Exceptions are propagated when you use one of the static or instance task.wait methods, and you handle them by enclosing the call in a try-catch statement. If a task is the parent of attached child task, or if you are waiting on multiple tasks, multiple exceptions could be thrown. To propagate all the exceptions back to the calling thread, the task infrastructure wraps them in an aggregate exception instance. Aggregate exceptions has an inner exception property that can be enumerated to examine all the original exceptions by using the AggregateException.handle method. Let's take a look at the demo now. Okay, so here we have our console application. Let's add some code to see how exceptions handling works. First of all, we're going to create a custom class extending the exception class of the .NET. Now, let's create a task, and inside that task, we're going to throw our custom exception. Now, we're going to execute the task and create some exceptions handling mechanism, which is going to allow us to understand what is the status of the task by its completion and inspect the inner exception if there is any. All right, now let's take a look on how it works. As you can see, the exception was thrown from within our code. Let's click Continue. And now we have got this exception from the task and interpreted it in the correct way. It is important to mention that if you do not wait on a task that propagates an exception or access its exception property, the exception is escalated according to the .NET exception policy when the task is garbage collected. Another important aspect of exceptions handling is child tasks and nested aggregated exceptions. If a task has an attached child that throws an exception, that exception is wrapped in an aggregate exception before it is propagated to the parent task, which wraps that exception in its own aggregate exception before it is propagated back to the calling thread. In such cases, the inner exception property contains one or more aggregate exception instances, not the original exceptions that caused the fault. To avoid having to iterate over nested exceptions, you can use the flatten method to remove all the nested exceptions, so that the AggregateException.innerExceptions property contains the original exception. Let's see how it is working. Let's continue from where we left in our previous demo, but now let's modify our code to see how internal child tasks exceptions can be handled properly. Let's make some modifications to our code. Alright, so we have performed some modifications where we, instead of having one single task, we attached child tasks which are created within a parent tasks. We have several levels of nested tasks, and from all of them, we are throwing some exceptions. Now, in try-catch block, we will not be able to access exceptions properly because they are nested. Here, they're going to be nested inside 3 aggregate exceptions, and in this case, they're going to be nested inside 2 aggregate exceptions. So here we need to use a method flatten in order to bring nested exceptions some levels up to the most parent exception returned back. Let's see how it works. Okay, we can observe the first nested exception being thrown. Now we can observe the second nested exception being thrown. And now we can observe that because of usage of flatten method, all the inner exceptions were flattened to the most parent exception thrown, so we can access those exceptions properly. By default, child tasks are created as detached. Exceptions thrown from the detached tasks must be handled or rethrown in the immediate parent task. They are not propagated back to the calling thread in the same way as attached child tasks propagated back. The topmost parent can manually rethrow an exception from a detached child to cause it to be wrapped in an aggregate exception and propagated back to the calling thread. A good technique to observe the exception property of a faulted task is to use a continuation that runs only if the antecedent task faults. In other words, if a task completes in the task status.faulted state, its exception property can be examined to discover which specific exceptions caused the fault. Let's take a look at the demo. Now, let's continue with our previous demo to understand how we can use continuation in order to grab the exception that was thrown by the task. Let's move some levels back so we have a simple task instead of nested tasks. Now we're going to add some code to look at how continuation for exceptions works. Okay, so we have made a modification, including the continue with method, which is going to allow us to inspect the exception of the task. But the task is not always throwing the exception, so here we have a special case where we need to include the task continuation option, so we indicate that the task should continue only when it's faulted. Let's run the code and see how it works. Here we have our exception being thrown. Let's continue. And now we can see that the continuation have worked properly. It's indicated that the custom exception was thrown and the message from within the exception.